Welcome to Maths with EJD. I've been making videos on calculus lately, and in the first video, I actually talked about graphs of functions of real variables. In this second video, our focus is shifting to operations on functions of real variables. And those operations are very simple. They are inversion of functions of real variables and compositions of functions of real variables. You remember when I was taking matrices, I was talking about matrix inversion and things like that. See here, functions also have inverses, and that is one of the things we'll be learning in this video. Okay, so let's talk about inversion. So inversion of functions of real variables. The inverse of a function is a function that reverses it. So any function that reverses another function is actually said to be the inverse of that function. So for instance, the inverse of an inverse, every function is an inverse of its own inverse. So if you say f inverse of x inverse, that will give you f of x, right? That will give you f of x. So it's just like you have 1 over x. The inverse of 1 over x is x. So the inverse of x again is 1 over x. Like if you find the inverse of the inverse of a function, it ends up giving you that original function you started with. So that's basically the idea here. Okay. So um, how do we find the inverse of a function? In order to find the inverse of a function, we make the independent variable dependent by making it a subject of the function. I remember the first time I came across the idea of making something the subject of a formula. It was in the third year of junior secondary school. So subject of formula. So that's the kind of idea we're using here. So if you have a function y equals something something x, so to find the inverse of that function, you make x the subject of formula, and after making x the subject of formula, then you can now, so once you're able to make x the subject of formula, then you change x to y and y to x, and then that's the inverse of the function. So let's go to the next slide, which is 26. Yes, a very good example. We want to find the inverse of the function f of x equals 1 over 2 x over 2 1 over 2 x minus 2. So you have the function here, and then of course to make it easier, instead of f of x you can say y is f of x normally. So you have y equals 1 over 2 x minus 2, and don't forget the goal is to end up making x the subject so that you can express x in terms of y. So the first thing we do here is to multiply through by 2. So multiply this by 2, multiply this by 2. So these two cancels out. So you have 2y equals x minus 2. And since you have 2y equals x minus 2, you can divide through by, okay, yeah, we want to make x the subject, right? So you can transfer the 2 to the other side. That is like 2y plus 2. And that's why this line is x equals 2y plus 2. And once you have succeeded in making x the subject of formula like this, you can now say, therefore, the inverse, f inverse of x is 2x plus 2. That means that the inverse of 1 over 2 into x minus 2 is the same thing as is f inverse of x, which is 2x plus 2. So it's a very simple process. Make x the subject, and once you have done that, then change y, this y, change it to x, and then the function you get is actually the inverse of the original function. It's a pretty simple one. Okay, so that's one example. Let's check another example, something a bit more difficult. So we want to find the inverse of the function f of x equals 1 over square root of 9x minus 1. Okay, so this is the function f of x equals 1 over square root of 9x minus 1. To make things easier, instead of f of x, we say y, because it's easier to handle y. So y equals 1 over square root of 9x minus 1. So the next thing to do is, there's square root here. We want to make this x the subject. So everything disturbing x, we have to get rid of it. So the first thing is the square roots. So we can take the square root of the square. To remove square root, to take square of both sides. So you say this square and this square too. So that's why this is y squared, and 1 squared is 1. Square root of 9x minus 1 is just 9x minus 1, because square root times square root it cancels itself out. So you have this expression now. And then the next thing is you multiply through by 9x minus 1. So you have y squared times 9x minus 1. Or so what we call cross multiplying, you have y squared over 1 equals 1 over that. So 1 times 1 is 1. Then you have y squared into 9x minus 1. So that's why here you have y squared into 9x minus 1 equals 1. So the next, don't forget, the goal is to make x the subject. So if you want to make x the subject, you better transfer y, and that's by division. Since y squared is multiplying this, you divide both sides by y squared. So you have 9x minus 1 equals 1 over y squared. Things are getting better. The next thing is minus 1 is disturbing this. So transfer the minus 1 to this side. That's why you have 9x equals 1 over y squared plus 1. So if you take the LCM, y squared and y, the 1, the LCM is y squared. Y squared is y squared, 1. 1 times 1, 1. 1 in y squared, y squared. Y squared times 1 is y squared. Okay? So then it means you have 9x equals 1 plus y squared divided by y squared. So the last thing to do is to just divide both sides by 9. You know, you can divide both sides by 9 like this. So this cancels out, and you just have 1 plus y squared over 9y squared. So after you have successfully made x the subject of formula, then change all the y to x. So you have 1 plus x squared over 9x squared. And then instead of x, you just say the function now that you have now is the f inverse of x. So it means that the inverse of 1 over square root of 9x minus 1 is the same thing as 1 plus x squared over 9x squared. Very interesting process, but you need to know what to do at every point in time. Don't forget, to remove square root, you square. To remove square, you take square root. To remove something multiplying something, you divide. You know, to remove something added to something, you subtract. To remove something subtracted from something, you add. So those are like reverse operations to get rid of things that may be disturbing the x you're looking for. So we have yet another example to drive this point home. Find the inverse of the function f of x, which is 1 plus x over 1 minus x. So again, you have f of x equals 1 plus x over 1 minus x. So to make things easier, as usual, make it y. So you have y equals 1 plus x over 1 minus x. Don't forget, we need to make x the subject. So the next thing you want to do is to multiply both sides. I mean, cross multiply. So you have y times 1 minus x and 1 times 1 plus x. And that's why you have 1 plus x here, y into 1 minus x here. So you can you can expand. So you can expand and you have y into 1 minus x. That's y times 1, y times x, xy. Then you have 1 plus x here. Don't forget, the goal is to make x the subject. So what we do here is to, um, you know, because I want to deal with less minuses. Normally, I can move x here. If you move this x here, that will be minus xy minus x. And I think I've always told you to avoid minuses as much as possible. So it's better to make a smarter move. So move xy here. So that's why you have x plus xy, and move y here. So that will be y minus 1. So you have x plus xy equals y minus 1. Okay, so things are coming together. So here now, you have the x's together, no x elsewhere. So you can factorize. So you have x into 1 plus y, and that is equal to y minus 1 here. So things are looking neat. So you can divide both sides by 1 plus y or y plus 1. Same thing, y plus 1 or 1 plus y. So finally, this cancels out with that 1. And then you have x to be equal to y minus 1, y plus 1. So now change all the y to x. So y becomes x, y becomes x. So then once that is done, whatever you have now is automatically the inverse. This is now the inverse of this original function, like that. So with those 3 examples, you can go over them or you can try them yourself to master the process if this is new to you. That's how to find the inverse of a function. Okay, so that leads us to the idea of composition of functions of real variables, composition of functions of real variables. So the idea of composition is like you are putting 2 functions together to form one. That's the idea. And a very good example of this is in the context of marriage, right? For instance, let's use an interracial marriage, so to speak. Like maybe a white person gets married to a black person. Pardon the use of those words because I know it's an issue in some quarters. So, they have a kind of child that looks white and black at the same time. That has some features for, okay, well, generally, right, in marriage, so when children are born, you see the children have features of both parents. So you can now say that those children are the composition of their parents. That's a very good example of what composition of functions of variables look like. So the composition of functions of real variables, right? If f and g are functions of real variables, the composite function f, so this is how it is written now, this thing that looks like O, f of g, or you can say f composed with g, is defined by f of g, which is f of g of x. That means f is swallowing g of x. Whatever x was, g of x takes its place. You're going to see very good examples of this. And then the domain of the composite function, the domain of f composed with G consists of the numbers in X, the numbers X in the domain of G, for which G of X lies in the domain of F. Now that sounds like a lot of grammar, right? But the idea is that, so if the functions for which G of X is defined, by the time you put G into F, so the domain of this composition will be the values of X for which the original G is defined. That sounds somehow, but let's go into practical examples so you can get the gist better. Okay, so we have this. Okay, we have, I guess I need to use something brighter. Okay, so you have, if f of x is x plus 5 and g of x is x squared minus 3, then you are told to find f of g of x, g of f of x, f of x, g of x, f of g of 0, g of f of 0, f of minus 5, and g of 2. So don't forget, f of x is x plus 5 and g of x is x squared minus 3. So to find f of g of x, so that means f of g of x is, it means, normally there's f of x, right? So now the x is now taken over by g. So you have f of g of x. Whatever x was, g takes it over. So don't forget, the original x was, so the original f of x was x plus 5. So it's not like g is taking the place of this x. So instead of just having x here, you are going to have g. And this is g. G is x squared minus 3. So g now takes the place of this. So you have x squared minus 3 plus 5. G takes the place of x. So that's why you have x squared minus 3 plus 5. So if you expand that, you have x squared minus 3 plus 5. That is x squared plus 2. So that means that if you put g into this function, the f composed with g of x is actually x squared plus 2. So that's putting the two functions together. And all that grammar I was trying to explain before is that, this function g is defined for every real number. I mean, we are not dividing by anything, right? So it is defined for, pick any number, this function is defined. So the same thing happens here. So it means that the domain of definition here, that means x belongs to all the group of all real numbers without exception. And so you can see the same thing applying to this f of g of x right here. So that's f of g of x found. So the next thing we need is find g of f of x. Let's see, is f of g of x the same thing as g of f of x? Let's see if that is true in slide 31. Slide 31, yeah. So look at this now. So g of f of x. So we have g of f of x. Now g of x normally has its own expression. G of x, as if you remember, is x squared minus 3. Then so f of x is taking, so this is where x was. So f of x is going to take the place of this x now. So f of x itself is x plus 5. So you now have, so look at what I did here. So I say g of f of x. So it means that you have f of x is x plus 5. So you have g of x plus 5. So normally g of x is x squared minus 3. So it means x plus 5 is going to take the place of, so it means g, what is it now? Yeah, it means x plus 5 is going to take the place of x squared. So you have x plus 5 squared minus 3. So if you expand this, there's a sharp way, like I said in one of the videos, x plus 5 squared. So square x, you have x squared plus 2 times x times 5, that is 10x plus 5 squared. That's why you have x squared plus 10x plus 5 minus 3. So 25 minus 3, that's 22. So you have g of f of x equals x squared plus 10x plus 22. Now you discover that f composed with g of x is not equal to g composed with f of x, except maybe for some specific kinds of functions like that. Okay, so let's find f of x. That's the next question. That means you're composing f with itself. You're composing f with itself. So you have f of x, that is f of x. So that is f of x plus 5. So you have x plus 5, and now instead of this x plus 5 is taking its place again. So that's why you have x plus 5, and that is x plus 10 right here. That is f composed with itself. Then you want to find g of x. So g of x, that's g of x squared minus 3. That means you have g of x squared minus 3. So g of x alone is x minus 3 all squared minus 3. So like what we did before, x squared that's x raised to power 4. 2 times x squared times 3, that is 2 times 3, 6 times x squared, that's minus 6x squared. Minus 3 times minus 3, that's plus 9, then minus 3. So tidy things up, you have x raised to power 4 minus 6x squared plus 6, and that is g of x. So we have f of g of 0. Now what this means is once you have put g inside f, then put 0 for x. So, we found it before. We found f of g of x before to be x squared plus 2. So f of g of 0 is simply put 0 for x and evaluate. So for x squared, then you have 0 squared plus 2. So that's 0 plus 2, and the answer is 2. So f of g of 0 is 2. F of g of 0 is 2. Then we go ahead to have this. You want to find g of f of 0. G of f of 0, don't forget, we found that to be x squared plus 10x plus 2. So just put 0 for x. So 0 squared plus 10 times 0 plus 22. And the answer is 22. Easy peasy. But of course, if you had not found it before, then you already know how to find it. So you go through the process and find that. Then, okay, this is slide 35. We go to slide 36 next. Okay, so now we are here. So we want to find f of minus 5. F of minus 5, that's f of x already. We found that to be x plus 10, if you remember. Then put minus 5. F of minus 5 means wherever you find x, put minus 5. So minus 5 plus 10 is 5. Done. Then you go for the next one. G of 2, that's the next thing to find. G of x was x raised to power 4 minus 6x squared plus 6. So put 2 for that. That's 2 raised to power 4 minus 6 into 2 raised to power 4 plus 6. So 2 raised to power 4 is 16. 2 raised to power 2 is 4 times 6, 24 plus 6. 16 minus 24 is minus 8, I think. Yeah, minus 8 plus 6 is minus 2. And g of 2 is minus 2. All right. So something a bit more complicated, which is also very interesting. So if f of x is 1 over 9x minus 1 and g of x is equal to x minus 1 over x plus 1, show that f of g inverse of x, that is when you compose f and g together and you find their inverse, it's the same thing as when you find the inverse of g first and find the inverse of f next, and then compose the two of them together. That's a very interesting result. Let's see. So first of all, you want to find f of g of x, based on this. So f of g of x means f of x minus 1, x plus 1, because g of x is x minus 1, x plus 1. But f of x itself is 1 over, so it's more like you have 1 over 9x minus 1. But then this x now is going to be replaced by g of x. So and g of x is this x minus 1 over x plus 1. So that's why you have 1 over square root of 1 over no square root, 9 into, instead of x now, you have x minus 1, x plus 1, minus 1. So, and then we do some tidy maths. So this goes up. So you have 1 over the else. So we can expand this. So you have 9x minus 9 over x plus 1 minus 1. So it's more like you have this over 1, and you take the LCM, x plus 1 and 1, that's x plus 1. X plus 1 in x plus 1, that's 1, times 9x minus 9. Then 1 in x plus 1, that's x plus 1. So that's why you have minus 1 into x plus 1. So we tidy that up. You have 1 up here, still here. Then 1 times 9x, 9x. 1 times minus 9, minus 9. Then minus 1 times x, minus 1 times plus 1. That's minus 1. So, and then we take that up again, and we have 1 over 9x minus 8 minus x is 8x minus 9 minus 1 is minus 10. So you have 1 over 8x minus 10 all over x plus 1, and that is equal to, of course, you have 1 over this over this. So x plus 1 automatically goes up. It's more like you have 1 divided by 8x minus 10 all over x plus 1. So that will be 1 times x plus 1 all over 8x minus 10. So that's why you have x plus 1 all over 8x minus 10. Okay, so you have this. And then the next thing is to tidy things up a bit. So 2 is common here. So you have 2 into 4x minus 5. 2 goes in 8 4 times, and times x minus 10 divided by 2, 5. So you see that f of g of x is settled, x plus 1 over 2 into 4x minus 5. So this is just the first step of this, right? So the next thing is to find the inverse of this, because we need f of g inverse of x. So the next slide shows us how to find that inverse. So you already know how to find inverse. To find f composed with g inverse of x, this is what f of g of x is. So make this y for easy handling. So you have y equals x plus 1 over 8x minus 10. So cross multiply, this over 1, this. So you have y into 8x minus 10, then 1 times x plus 1. So if you expand this, you have 8xy plus 10y equals x plus 1. Don't forget to find the inverse you're looking for to make x the subject of formula. So you can put all the x's together, bring x here, bring 10y here. So you have 8x minus x, 10, then 10y comes, so it's 10y plus 1. Of course, 1 plus 10y is the same thing as 10y plus 1. So factorize the x, so you have x into 8y minus 1 into 10y plus 1. Divide through by 8y minus 1, so you have x equals 10y plus 1 over 8y minus 1. So change all the y's to x. So you have, so it means that f composed with g inverse of x is simply 10x plus 8x minus 1. So we have found f composed with g inverse of x settled. So now the next thing is we want to see if that inverse now is the same thing as when you find the inverse of g and you find the inverse of f, and you now find g inverse of f inverse of x. So that's the next journey. So again, don't forget from the original question, g inverse of x, you remember g of x is x minus 1 over x plus 1. So based on that, we're going to find g inverse of x. So to find g inverse of x, so of course, you have g of x equals x minus 1 over x plus 1. Again, call this y as usual. So you have y into x minus 1 over x plus 1. Next, cross multiply. So you have y times x plus 1, 1 times x minus 1. So you have y into x plus 1, x minus 1. Y times x is xy. Y times y, 1 is y. Then you have x minus 1. So then this is taken up this way, so you have so you collect like terms. So xy minus x, that's this x going here, and this y is coming here. Of course, in this case, it looks like that's the best thing we can do with the minuses. So you have minus y minus 1, because plus y here becomes minus on the right hand side. So you have xy minus x equals minus y minus 1. Factorize x, so you have x into y minus 1. Then you can factorize minus, so you have minus into y plus 1. Divide both sides by y minus 1, so you have x equals minus y plus 1 over y minus 1. Interestingly, this is minus y plus 1 all over y minus 1. Now, this is the same thing as saying y plus 1 all over minus y minus 1. The minus up can come down. So you have y plus 1 all over minus y plus 1. So this is why this can now be 1 minus y. Of course, y plus 1 is the same thing as 1 plus y all over 1 minus y. So, I just like this arrangement for some kind of perfectionistic behavior, and then you see this is g inverse of x. So g inverse of x is 1 plus x over 1 minus x. Starting from x minus 1 over x plus 1, which is g of x, g inverse is 1 plus x over 1 minus x. Okay, so we are still on the journey. The next thing we need to find is f inverse of x. F inverse of x. So this is where we get to find f inverse of x. So to find f inverse of x, you have, again, don't forget the original question, f of x as given originally. is 1 over 9x minus 1. So we want to make x the subject. So you have y equals 1 over 9x minus 1. Again, cross multiply y times this, 1 times that. So you have y into 9x minus 1 equals 1. Then you have 9x times y, that's 9xy minus y equals 1. Then this is easy. You don't have to collect anything. So just transfer the y. So you have y plus 1 equals 9xy. So x alone is y plus 1 over 9y. So finally, the f inverse of x is change the y's to x. So you have x plus 1 over 9x. So now we have found g inverse of x and f inverse of x. So the last thing is to compose them together to see if it's equal to what we got before. Remember, we got f composed with g of x together before as something. So let's see if they are the same with this now. So we want to find g inverse of f inverse of x. So g inverse of f inverse of x means g inverse of f inverse of x in bracket. So g inverse of x, g inverse of f inverse of x is just what is what we just found, which is x plus 1 over 9x. That is f inverse of x here. So, but you remember g inverse of x itself is 1 plus x over 1 minus x. So that's why you have 1 plus g f inverse of x over 1 minus f inverse of x. That's what is happening. So you have, so instead of x now, f inverse of x takes its place. So you have 1 plus x plus 1 over 9x, 1 minus x plus 1 over 9x. So, I mean, some serious maths going on. So 1 over 1, LCM is 9x here. Then 1 in 9x, 9x. 9x times 1 is 9x plus 9x times 1. Then 9x in 9x is 1. 1 times x plus 1. That's what you have here. And for the bottom, same. So LCM is 9x. 1 in 9x is 9x. 9x times 1, 9x minus 9x in 9x, 1 times x plus 1. Feels like a lot, but you need to be careful to get it going. Okay, so the next thing is you tidy things up a bit and you have 9x plus x plus 1, then all over 9x. Then next you have 9x minus x minus 1 all over 9x. Again, you have the top, you have the bottom. So it's like 9x plus x is 10x plus 1 divided by 9x. Then all over 9x minus x, that's 8x minus 1 all over 9x. So you can divide, this like 10x plus 1 over 9x divided by 8x minus 1 times 9x. Divided means multiply by 9x over 8x minus 1. So 9x cancels 9x, so you have 10x plus 1 all over 8x minus 1. So that means g inverse composed with f inverse of x is 10x plus 1 over 8x minus 1. And this is exactly what f composed with g inverse of x was. So you see, g inverse of f inverse of x is 10x plus 1 over 8x minus 1. So we can conclude that f composed with g inverse of x is equal to g inverse composed with f inverse of x. The same will be true of g composed with f inverse of x equals f inverse composed with g inverse of x. So it's just a reversal of those expressions. Okay, so that goes. Interestingly, we've come to the end of that. So you have some exercise to play around with. You can try your hands on these things. Find the inverses of the following functions. As you can see, f of x equals 2 plus x over 1 minus 2x. F of x equals 2 over 3 into 4x minus 7. F of x is square root of 2x minus 11. Then function number 2, given f of x equals 1 over square root of 9x minus 1 and g of x equals x squared, find f composed with g of x, g composed with f of x, f composed with f of x, g composed with g of x, and evaluate them at x equals 7.5. So after you find each one, put 7.5 and see what the answer is. And now you want to show what I just established now, that f composed with g inverse of x is equal to g inverse composed with f inverse of x. And the reverse, g composed with f inverse of x is equal to f inverse composed with g inverse of x. If you can try your hands on this, I mean, you really like it. So of course, if you want to do the kind of graphs I did, you can use Desmos. Desmos is a very nice tool for plotting all these mathematical functions. And then if you need some reading material, you can use this very nice calculus textbook. So thanks for listening. The calculus journey continues. You don't want to miss anyone. See you in the next video. Make sure you've subscribed so that you can, and hit the notification bell so you can always get notified when I have a new video out. Thank you for listening. See you.